When we're simplifying cube roots and the variables inside are not multiples of 3, you will have leftover variables, just like we did when we were simplifying square roots. So for example, the cube root of 16, we'll do that separately, but the cube root of x to the 5th, if you expand, and I'm going to actually expand the whole thing. I'm going to write 16 as 8 times 2. So I'm pulling out that perfect cube. 1, 2, 3, 4, 5 x's, right? 9 y's. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, obviously, this is not a shortcut, but if you think about it, every 3, 1 comes out. And so therefore, these guys are not going to come out. The 2 x's there are not going to come out because you need 3. So 3 y's, 3 y's, 3 y's. And of course, our 8's going to come out because that's a perfect cube. The cube root of 8 is 2. There's 3 x's, 1 comes out. Y cubed. What stays inside the cube root of x squared? So keep track of what stays inside. Please remember to place the index in the radical symbol. Then another way to think about it is you could rewrite it as x to the 5 over 3 and y to the 9 over 3. Now, when you write it that way, it's not so easy to simplify. X to the 5 over 3 would just stay 5 over 3. Y to the 9 over 3 would be y to the 3rd. So it is possible to write it like that, but it doesn't simplify it as much. Let's try the second one, the cube root of negative 24. So again, we realized in the last section that we can have cube root of negatives. I'm going to pull the negative with the perfect cubed. So negative 8 times 3, and then x to the 4th, y to the 11th. Now this time I'm not going to expand it out. I know that the cube root of negative 8 is negative 2. I know that there will be a cube root of 3 left inside. There are 4 x's. 1 will come out, 1 will stay outside. 4 divided by 3 is 1, with 1 remaining. 11 divides 3 times, with 2 remaining. Adding and subtracting. So that's just simplifying. Now let's do adding and subtracting. So let's review. We know that we have to have like radicals in order to add or subtract. And what we do is we add outside to outside. So that's a 7, inside to inside. That stays a 3. Just like we did with square roots, okay? With cube roots, we have to make sure that we reduce them, and then we see if they are like before we can combine them. This is for adding and subtracting. When you're multiplying and dividing, you don't have to have the same numbers inside, but you do have to have the same index. So you can't multiply a cube root times a square root. Only a cube root times a cube root. All right, cube root of 24. That's going to be the cube root of 8 times 3. So that's 2, the 3 inside. Cube root of 48 is going to be the cube root of 8 times 6. 8 cube roots to 2 with 6 inside. Can you add them together? You cannot. We do not have like radicals. So your answer would just be the following. 2 cube root 3 plus 2 cube root 6. When you do have the same inside, you will be able to combine. So let's try this one. Cube root of 8 is 2. Cube root of x cubed is x. Cube root of 27 is 3. Cube root of x cubed is x. 2x plus 3x is 5x. 128. Now that's a fairly big number, so I've got to figure out what perfect cube divides into 128. So it's kind of helpful to have them listed. 1 times 1 times 1 and then 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216. Grab your calculator for that. 64 divides into 128 2 times. Again, use your calculator. So I'm going to break that into 64 times 2. You just have to remember that you're working with a cube root, not a square root. Cube root of 64 is 4, so 4 is coming out. A 2 is going to remain inside. The cube root of x cubed is x. There's already an x outside, so that's x squared. All right, 250. Well, for 250, we know 125 times 2 is 250. So the cube root of 125 is 5. The cube root of x to the 6 is x squared, with the cube root of 2 left inside. Subtracting 4x squared, subtract 5x squared, is a negative 1x squared, cube root 2. When you're multiplying and dividing, as I said, you do not need to have the same number. You just have to have the same index. So for this one, we would multiply everything on the inside. So that's going to be 7 times the cube root of 25 times 5 is 125, a cubed, b cubed. Cube root of 125 is 5 times 7 is 35. Cube root of a cubed is a, cube root of b cubed is b. For dividing, you should simplify inside the fraction first. So the rules of exponents say you're going to subtract when you're dividing. So 7 subtract 4 is 3. 2 subtract 8 is negative 6, therefore that pushes it to the denominator to make it be positive. Now you can separate cube root of x cubed, cube root of y to the 6, that simplifies to x, and then the cube root of y to the 6 is y squared.